Hi all, and after a long time, I just came back, and now I'm going to take some important topics, which is in the upcoming days, and like day-wise concept. And today we're gonna see some interesting one, okay, which is problem on trains, right? Problem on trains. Okay, so many thought that it will be a tough first one, or many think that this is not gonna be work in the exams. It's very easy because we need to know only 4 points. Okay, so let's see one by one. Case number one. Okay, we normally know there is a train means it will cross a tree. Yes, and then a bridge. It's need to cross a train and a bridge. Yes, or a man standing, or a man moving. Yes, so the train need to cross a tree, bridge, and a man crossing, or man standing. Okay, so these are the conditions. So let's see that. First one is if the train if the train crossing stationary objects. Stationary objects. What is this? What is the stationary object? Which is nothing but speed of this object will be equal to 0. There is no speed. Like the object is at the same place. It never move. Okay. So this is a thing. For example, so I can easily take some examples like tree. It won't move. And then platform. Yes, platform or station. Okay, after that, man who's sitting or standing. Yes, he can't move. He's he's at a rest position. Okay, so in these conditions we need to take the speed. Okay, speed will be equal to speed of the train. Yes, speed will be equal to speed of the train. Why? Because the object has zero speed means we can directly take the train speed. Okay, so we need to take the speed which is equal to speed of the train. Okay, for example, if a man is standing here, okay, and the train is crossing, if it crosses at 53 53 seconds, okay, 53 seconds, and it is going on a speed 5 kilometer per second or per hour means we can easily take this 5 as the speed of the train, because the man or a tree, okay, a man or a tree, actually it is in the stationary point, like actually it is in it doesn't move, it is in the same point means we can actually take the speed as train speed. Okay, so this is the first condition. Okay, and the second condition. Okay, what is the second condition? Case 2. If the train crosses moving object. Okay, moving objects. What may be the examples? Man, okay, man walking or jogging, okay, okay. Then another train, yes, another train. So these are the objects which is moving actually. So for example, if a man walk, he walks in this direction and the train is also moving in the direction, the same direction means, so both the things are moving. What can we say about the speed? We can easily take the speed as relative speed. Yes, it's a relative speed. What is that relative speed? Relative speed means two things: speed, speed of train plus speed of man, okay, or speed of train minus speed of man. It can be either one, okay. You can subtract from train to man, okay. So speed of train to speed of train plus speed of man. So this is what relative. We can either add it or we can either subtract it. How can we decide these two conditions? Okay, so the first one, addition. If the man moves in this direction, okay, and the train is coming in this direction, if these two objects are moving in the opposite, okay, opposite direction means we can easily add it, either this side or this side, okay. Man walking in this direction and the train is moving in this direction means, okay, opposite direction means just add the speeds. Whereas same direction, okay, if a man is walking in this direction and the train is also moving in the same direction means we can easily subtract it, just two things in the relative speed. Yes, speed. If the object is stationary, we can easily take the speed which is equal to speed of the train. If the object is in moving condition, we can directly take the speed as relative speed, like either add those two speeds or subtract those two speeds. Okay? Okay, then what will be the third condition? Third case. Okay, case 3. That is, if the train crosses an object which is negligible length. Negligible length, okay. So this is the main thing. Negligible length means we can't compare that length with the train, like a man and a train, okay. So in this thing you can easily say that train is easily crosses the man, right? So this man has the negligible length. We can't compare this length to the train. Yes, yes. But in case of platform, it has some length, right? The platform has some length. So this won't come in this negligible length. Only a man or a tree or a poles. Poles, right? Poles. these things will comes in the negligible length. Okay, so let's see that this is all about distance. Okay, this is all about distance. Okay, if a train crosses an object which is negligible length, then we can take the distance as, what is the distance? Nothing but length of the train, right? Because the train only has the length. Here the man or the tree or the pole doesn't have any length, right? So we can easily directly take the distance as length of the train. Yes. Okay. Then what will be the case 4? The last one. Okay, case 4. Okay. If the train crosses the object which has some length. Yes. Example, what it would be? I can easily say bridge, right? Platform, yes. And then station, yes, obviously. Station, what else would be? So these are the things which has, what to say, which has a distance. Like another train, yes, another train is also has some length. So a train crosses another train. So these are some examples. So in this condition, I can easily tell it comes under fourth case because two objects and these two objects has two speed, right? It has a 4 kilometer per hour or 2 kilometer per hour. So it has some speed and it has some length, right? T1, T2. So we need to take case 4 and then just see in these two cases which case will come under two trains. This case is not because that uh, the object should have zero speed, right? But here the two trains has speed. So train number 1 and train number 2. So this case will come, right? Like case 2, case 4 and case 2 will come under this. Case 2 means what? Speed, we need to take the relative speed. Yes, if the two trains are moving in the same direction means we need to subtract. If it is moves in the opposite direction means we need to add. That's it. So speed will be equal to relative speed. Okay, what will be the fourth condition? Fourth case. This fourth case is nothing but distance will be equal to length of train 1 plus length of train 2 thing in the fourth case. So whatever may be the thing, train or bridge, train or platform, we need to take the length, distance, sorry, distance will be equal to length of train plus length of platform. So this is the fourth case. Okay. So we know four conditions, right? We know till now four conditions. The only formula, simple formula we need to apply is nothing but speed, which is equal to distance by time. We know this formula. So we can easily write time will be equal to distance by speed, right? So these are the two formulas which is very important for this train sum. So we can easily use these two formulas to solve any kind of problems by using this four cases, right? Okay, and one more point I need to tell you. Many have a doubt kilometer per hour to meter per seconds. How can I change it to kilometer per hour to meter per seconds? Okay, so I can easily write 1 kilometer. This is all about speed units. Yes, okay. 1 kilometer by 1 hour will be equal to, I can easily write this kilometer as 1000 by 60. I'm just changing this hours to minutes, 60. And again, minutes to seconds. Like hour to minute means into 60, minute to seconds means into 60. So from this thing, I can easily say 5 by 18 meter per second. Yes, so 1 kilometer per hour will be equal to 5 by 18 meter per second. Yes, 1 kilometer per hour will be equal to 5 by 18 meter per second. I will always remember the smaller number to the smaller one. If I say 1 meter per second will be equal to 18 by 5 kilometer per hour, right? So here you can see bigger number to the bigger unit. So I easily remember like this. So this is the main point. Okay, let's see a sum. So first read the sum. A train 108 meter long. So they have given the train number 1 distance. Moving at a speed of, they have given the train speed of train 1. Crosses a train, another train. So this train has the speed 50 kilometer per hour and it crosses another train 112 meter coming from the opposite direction. So the relative speed we need to add, right? Because it is moving in the opposite side. This is case 2. And the distance we need to add. This is case 4. Yes. What is the speed of second train? And they have given one important thing, 6 seconds. So these two trains crosses each other at 6 seconds. The 6 second relates these two trains, right? Train number 1 which has some length and train 2 which has some length. These two trains crosses each other in opposite direction in 6 seconds. And they have given the speed of first train as this and we don't know the second train. So I need to write whole speed, distance and time. Okay, so we need to first write whole things. So what is train number 1? Train number 1, distance, speed and time. Okay, so this is distance, speed and time. Okay, yes. So what is the train number 1 distance? 108. Train number 2 distance? 112, which is in meter. Okay, what will be the speed? 50 kilometer per hour. Note it, it's in kilometer. And what will be the second one? We don't know. I'm just taking it as EX. Then, what is the time? They didn't give these times, but they have given the total time as 6 seconds. That's why I just said we need to find the whole thing. So, whole means speed. According to case 2, what is speed? Which is nothing but relative speed, right? What is relative speed? Like it's in opposite direction, so we need to add it. Yes, so I'm just taking train 1 plus train 2 speeds. What is train 2? Which is nothing but x. What is train 1? Which is nothing but 50, but it's in kilometer per hour. So whenever I need to change from kilometer to meter, meter per second, right? Meter per second. Meter is the smallest unit, so I need to multiply by smallest number first in the numerator. 5 by 18 into the whole thing, 50 plus x. Yes, so 50 plus x into 5 by 18, which is in the meter per second. So this is the speed. I just found the whole speed. Yes. Then, according to case 4, what will be the distance? Distance which is equal to length of train 1 plus length of train 2, right? What is the length of train 1? 108 plus 112, which is nothing but 0, 2, 2 meter. So this is the distance. So obviously we know the speed, we know the distance, and we know the time for the whole. For the whole cases, 2 trains, we know the distance, speed, and time, right? So I'm just doing comparatively for the 2 cases. Okay, so for the train 1 and train 2, the whole, right? The whole thing, what is the distance? Just now we see it, 220 meter. What is the speed? Which is nothing but 5 by 18 into 50 plus x meter per second. Okay, what is the time? They have given in the question 6 seconds. Yes. So, we know the formula. Time which is equal to distance by speed. Right? Okay, what is the time? 6 seconds. What is the distance? 220. What is the speed? 5 by 18 into 50 plus x. So I can easily write, just cross it. Okay, just cross it. I can easily write this as 5 by 18 into 50 plus x, which is equal to 220 by 6. Yes. So if the equation, if the equal to symbol is here, means we can use a box method. Box method means cross we need to multiply, but cancel, we can cancel in a box type. We can cancel here, we can cancel here, we can cancel here, we can cancel here. Easily we can cancel in the equal to symbol. But cross means we need to multiply. This is the box method. So you can see here. So we can cancel here and here and here and here. If I need to multiply means I can easily do 5 into 6, 18 into 220. But I can easily cancel here, here and here, 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 here. Right? So I can easily cancel this. Just see, 6 threes are 18. Yes. And the top one. 5. 5 fours are 20. Again 5 fours are 20. Yes, so I'm just cancelling these two numbers and these two numbers. This box type. Okay. Okay. So what is the thing here? 50 plus x, which is equal to this 1 by 3 will come here. So 3 into 44. Up to this we have found it. So x will be equal to 4 threes are 12. Remainder 1. 4 threes are 12. 13 1 32 minus 50. Right? So x will be equal to, so just separate it. You don't need to subtract, do all these things. Just separate 30 and 20, right? So the 30 will go here. So it will cancel it and it will give 102 minus 20. So 100 minus 20 is 80. So 80 plus 2, 82. X will be 82. Meter per second. This is the speed, right? Speed of second train will be 82 meter per second. Yes. So, wait. Speed which is equal to what? 82 meter per second. So, I need to change this to kilometer per second. Yes, I can easily write this as 82 into, there is a bigger number, so numerator will be bigger, 18 by 5. By solving this, you can easily get the speed. Kilometer per second. So, if the options are given in meter per second, we can easily write 82 is the answer. Okay, so this is a simple sum and you can easily calculate it by using case 2 and case 4, right? You can see here case 2. Just find the speed for the whole thing and just find the distance for the comparatively for the two objects. You can easily get this one, and so we know distance, speed and then time. So from this we can easily say time equal distance by speed. Just substitute it and you will get the x value as 82. So in the option you can easily pick 82 as this. So this is all about the train problems. Okay, it's very easy and it's very simple too. Okay, this is the concept. Just 4 points. You need to remember just 4 points. Stationary objects and moving objects. This is all about the comparison of speed. And then distance. Okay, so negligible length. These are the negligible length. These are the objects which has the length. If the object has a length, the length will be length of the platform plus length of the train. If it doesn't has any length, like it is the object has a negligible length, means just take the distance as length of the train. Yes, so this is the last one, fourth case. Okay, so from these two cases we can easily find anything by knowing this formula. What is the formula? Speed equal to distance by time, or we can easily write time equal to distance by speed. And just know it, 1 kilometer per hour we need to change to meter per second. This is a smaller one, smaller unit, so I need to use smaller number, 5 by 18. And here kilometer, so I need to use 18 by 5. That's it. So these are very important for the exam. And this is the first day and I have done with the first concept, problems on train, right? So see you in the next class with some interesting, and this is the first concept in the first day, right? In the upcoming days I will come with some interesting concepts also. This is very important for all the competitive exams. Okay, see you in the next class. Bye bye.